So, and then if you have any questions, ask me. Err on the side of caution. If you're not sure if it's working, it's like all right, everybody, welcome to the second most important day of your life. The fundamental theorem of calculus will be all new markers. The fundamental theorem of calculus will be Wednesday. It's a new erasure, yes. I'm wearing all clean clothes and ready to go. So, yeah, there's a new haircut recently, etc., etc. Alright, so, I want to pass back to, oh yeah, the anti-differentiation quizzes. So we just quickly go over this. I thought this quiz was pretty easy, actually, guys. So, here we go. 2x squared minus 5x minus 7 over x minus 3. This is a rational function. Anytime you're trying to anti-differentiate a rational function, you should do polynomial long division. If the degree of the numerator is greater than or equal to the degree of the denominator, which it is. You have to do the polynomial long division correctly, so it's worth double checking that. You get 2x squared minus 6x. That's x minus 7. That goes in once. Some people just stopped here. That was weird. And you get x minus 3, and then you get negative 4. So this thing actually becomes 2x plus 1 minus 4 over x minus 3 dx. And at that point, you can probably just finish it off in your head, right? Because the antiderivative of 2x is x squared, the antiderivative of 1 is x, and the antiderivative of this is negative 4 ln absolute value x minus 3 plus c. Any questions? It took me 40 seconds. Number 2. Antiderivative of cosine of 3x over cube root 1 minus 2 sine 3x dx. Okay, people tried some very, very complicated, weird things that took a long time, but the simplest thing to do is, if I can somehow have an opportunity to make my denominator a single term, I take it. So what if I try to let u be 1 minus 2 sine 3x? Well, I think that's going to work, right? Because the derivative of sine 3x is cosine 3x, give or take coefficients, and so that's just going to work out. So if I just let u be 1 minus 2 sine 3x, then du is, that dies, and so I get negative 2 times derivative of sine 3, derivative of sine of something is cosine of the something, back inside from the derivative of the something. So, du is negative 6 cosine, negative 6 cosine 3x dx, which is almost exactly what I have up here. It's missing only a negative 6, so I put in the negative 6 and I undo the damage with a negative 1/6. Then I rewrite this as negative 1/6. The top is du, and the bottom is cube root u. I also take the extra step to rewrite it in anti-differentiation friendly form as u to the negative 1/3. So that's negative 1/6, and then that's up a power, so 2/3, so 3/2 u to the 2/3 plus c. Final answer, negative 1/4 u to the 2/3, so 1 minus 2 sine 3x to the 2/3 plus c. Questions about that? Okay, good. Next thing I wanted to do. Oh, did I just pass back the Wallops packets? I did.
Last class.
All right. Do we have any? Actually, just do we have any lingering questions about this? Or you guys feel like you mostly got this anti-differentiation under control? Okay, good, perfect. How about this packet that was due today? I asked you to finish this packet, which we had done maybe 60% of it in class, or maybe even more than that. there are a couple of hard problems, especially towards the end. Let's go over, hey Anthony, you're keeping an eye on this thing, right?
Yeah.
Okay. So let's go over some of those now. Which ones are hard? Newman, which ones are hard?
33.
33?
32.
Were those the ones at the end?
Yeah.
Yeah, okay, yeah, those are hard. How about anything, how about some ones from previous pages? Twenty-four. Alright, I'll just start and then maybe you guys have some other questions. So 24 was antiderivative 1, or really just dx over x root x to the 4th minus 4. Okay, this looks scary because there's a 4th here, that's kind of scary. And also, it looks kind of superficially like it might be some kind of arc-secant problem, but only if that were like x squared or something like that. I don't know, it seems weird. But I sort of generally see the outlines of an arc-secant situation, and the pattern I'm looking for with arc-secant is like that one, right? This would be arc-secant absolute value x. Let's see. So keeping that in mind, maybe if I make a substitution where I make this x to the 4th like u squared, that seems like a good idea. So I'm just going to try that. So if I let u be x squared, then du is 2x dx. Now I'm starting to see what happens. I need a 2x up here, right? So if I put that in, if I put in a 2x, and then undo the damage on the outside with the 1/2, and cancel the fact that I put an x up there with an x, by putting an x in the bottom also. Now suddenly everything is good. This is 1/2, the top is du, and the bottom is u root u squared minus 4. And now I have it in arc-secant form, except for the 4, of course. So now I just have to deal with that. Are you guys with me? Okay, so now, but I still do have to deal with the 4, so let's deal with that. So it's du over u root, factoring out the 4, that's 4 u squared over 4 minus 1. Okay, so if I take the 4 out of the square root, it becomes a 2, and if I take it all the way out, it comes out here. So I end up with 1/4 du over u root u over 2 squared minus 1, like that. Nice and slow and careful. Well, at this point I need to make one more substitution. I let w be u over 2, then dw is 1/2 du. So I need a 1/2 up here. So I've put in a 1/2. But as I'm doing that, I realize I kind of also need to put a 1/2 in the bottom to make that u a w. So actually those two moves cancel each other out perfectly. You see what's going on? You have to be very careful with your coefficients if you actually want to get the problem right. So now that I make the substitution to rewrite it all in terms of w's, it is just dw over w root w squared minus 1. That's arc-secant. So final answer, 1/4 arc-secant w, absolute value w, which is u over 2, so x squared over 2. Let's see. Are we good? Anthony, can you keep like maybe more of an eye on the actual camera? Or we can maybe do it in shifts.
It's done.
Good?
Yeah.
You sure? Are you confident?
Yeah.
Okay. All right. Other questions, 32 and 33. Let's do one of those. Or let's do whichever one's harder. Or are they just both hard? Let's do 33. That seems harder. 33, all the problems on this back page, I essentially warned you, were of the variety of try something, hope it works. And generally following the pattern of I like things in my denominator to be as simple as possible, and I don't like square roots. Okay, I have no idea what to do here, but I have no idea what to do here. Let's let u be root x minus 2. Does that seem like a good idea?
Yeah.
I don't know. So if I let u be root x minus 2, then hopefully it will just work out. That at least gets rid of square roots, so that makes me feel better. Alright, so let's see what happens now. If u is root x minus 2, well, first of all, then du is 1 over 2 root x minus 2 dx. Okay, that seems troublesome because I don't have that in there, so I'm not sure what to do. But let's solve for dx. So what is dx? Dx is 2 root x minus 2 du. And if u is root x minus 2, then that means that u squared is x minus 2, squaring both sides, and that in fact x is u squared plus 2. And now let's just try to convert everything to u's. Well, that guy is a u. Dx, as I just calculated, was 2 root x minus 2 du over, what's x plus 1? Well, x plus 1 would just be u squared plus 3. Alright, so now I've sort of partially converted it, but I still have some x's, but those can be just sort of gotten rid of again with like another u, right?
Yeah.
So then this becomes 2 u squared du over u squared plus 3. And that makes me feel pretty good, because that's just a rational function. I know how to deal with that now. So let's do it. So 2u squared divided by u squared plus 3, it's going to go in 2u squared plus 6. It's going to go in like that many times. So this is actually just 2 minus 6 over u squared plus 3 du. In other words, yeah, that's right? Yeah, so I end up with, my answer is 2u minus 6, and then it's just du over u squared plus 3. And now that is going to be an arctan situation, so I have to just like do that now. So 2u minus 6 u, and it's a little bit gross because I'm factoring out a 3, so it's like u squared over 3 plus 1. And then, so I get 2u minus 2 du over u over root 3 squared plus 1. So finally, I let my w be u over root 3. dw is 1 over root 3 du. I need a 1 over root 3 up here, and I undo the damage with the root 3 on the outside. So this becomes 2u minus 2 root 3 antiderivative dw over w squared plus 1. Am I going too fast, or kind of just going right through it? So final answer, 2 root x minus 2 minus 2 root 3 arctan w, which is actually root x minus 2 over root 3 plus c. All right, that's pretty hard. More. Aaron Sager, how you doing with all this? Goodish? Goodish. Okay, Ethan, other questions? Can I have this packet? could I have his packet right here, please? Yeah. Yeah. So what, you printed like a new copy for some reason?
Yeah, because I couldn't find the old one.
So you actually have the old one or you don't have it?
I think I may have the old one.
But you may not.
Yeah, but you gotta go.
Yeah, you turn it in and you can write it down like. Too late? Okay. You're like absent. What's the I don't know. Are you keeping up with things? Alright, can we put some of these homework problems up on the board from this worksheet?
Oh yeah, right.
Let's do that. In fact, if someone could erase the front board for me, that would be great.
David, you gotta press down there.
No one? Oh, yeah, someone's good. We are putting these up. We're putting these up on the board. So as soon as I make a space, if you want to grab a marker and come up right behind me. How'd this worksheet go?
What did you think?
It was annoying? For each one, can you put the original problem up and draw a very nice picture and then give your answer? And then we'll do the same thing back.
Wait, do we have to show work?
I just like thought about it. Okay, we're on. I can write this and I just like.
Yeah, you're supposed to just make a picture. Chris, put a problem up, please.
Is that?
Well, I'm doing.
No, I'm writing stuff down. It's like.
I was taking you up.
Okay, wait, so 3. I'm just gonna write with you.
Take care enough.
This problem.
I'm going
Make sure to write neatly and clearly for other periods too, so you know.
She's like, nah.
Wait, how much do we write?
Can you like draw a picture? Just so like, even if you sort of did it in your head, can you draw a picture anyway that kind of explains?
Okay.
Well, I feel like it's warm out. I just brought
I don't know how much.
Oh my god, I'm so stupid.
Someone doing 17.
God, the difficult.
Someone doing 17?
Oh, that's your problem yet? Your problem yet?
You know what?
Do another.
6, we're doing 5? No one's doing 5.
Do you think this is like a good like explanation?
You did more than I did.
All right, let's start. Skylar, how's it going?
I mean, I don't know how much to write.
Okay,
I just wrote
It's awkward.
maybe I'll just kind of take over. So Yeah. So here, this is kind of like backwards. This is like a backwards process now, right? Instead of me giving you an integral and you figure out what it is by converting it into a Riemann sum, instead I'm giving you a Riemann sum, the limit of a Riemann sum in fact, and I'm testing, is your understanding of integrals so good that you can figure out what integral this is by just looking at the Riemann sum? So, is this right? I don't think so, actually. Yeah, it's not right. So this is just kind of like, I think it's like that or something like that. But right, not. This is like not good enough, right? This is why I want this. I want you to really think about what's going on here. These problems are kind of hard. What is happening? Well, first of all, I'm taking the limit of a sum. Okay. I'm summing what? Well, I'm summing the product of two things. So I think it's natural to think of this as the width of the integral, or width of the subinterval, and this is kind of like the height, right? All right. So I seem to be adding up n things. So it appears that that my number of rectangles, is n. And the width of each, I'll just call it delta x, the width of each is 3 over n, which implies that my interval is going to be 3 wide, right? Interval has width 3. All right, and what do I seem to be plugging into the function? I seem to be plugging into the function. Well, there's actually a couple different ways to think about this. Either I'm plugging into the function, either the function is x squared plus 1, and I'm plugging in this expression, or maybe there are other ways to do it. So let's think about it that way. Let's think about it as the function is x squared plus 1. Well, if that's my function, let's try to graph it. Then what is the first number which I plug into the function? For example, when n is 1, or rather when I is 1, what am I plugging into the function? I'm plugging into the function -2 plus 3 over n. Right? You can actually just write that out for yourself, right? If that helps, I bet it does help. When I is 1, what rectangle is it? Well, it's the rectangle -2 plus 3 over n squared plus 1 is the height of that rectangle. How about when I equals 2? What's the height? Well, it's going to be -2 plus 2 times 3 over n squared plus 1. Does this look familiar?
Yeah.
Yeah, so it seems as if I'm starting out here at -2. And in that case, I would be ending at 1. So what I think we have is a picture that's something like this. Oh, I forgot the plus 1. Thanks, Sage. Sorry. So that's actually going to be like 5. Cha-cha. 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 Picture not perfect. But generally speaking, that is the area I'm going to be finding. And to sort of make this all make total sense, just think about it as if, so what I think the answer is it's the integral from -2 to 1 of x squared plus 1 dx. And if someone gave me this integral, that would represent this area, and then how would I find this area? Well, I would have a width of 3, I have n rectangles, so I'd split it up, and if I used Rm, then, that's kind of exactly what I would get, right? That would be -2 plus I, or plus 3 over n, comma f of that, and the next point would be -2 plus 2 times 3 over n, f of that, etc. Everybody with me? Okay. So, good. Does anybody answer this question differently? There's actually another correct answer. No, what? Raise your hand if you got this answer. Oh, okay, almost everyone. I think there's another correct answer.
Doing like x minus 2.
Yeah, if you think of it instead, if you think of the function, if you thought of the function as x minus 2 squared plus 1, then that would also be correct. But now, you'd be taking the integral from 0 to 3. And that is also correct.
But also just keep moving it over and over.
You can, yeah, you can move it over. Yeah, you could. There's actually an infinite number of correct answers, but these are maybe the two natural ones. And the rest of this worksheet is kind of there to sort of convince you, among other things, that these two integrals are the same because one's just kind of the shifted over version of the other. You guys see that? Okay, number 2 is kind of the same sort of a thing. Now it appears that my arbitrary term is pi plus some amount. And the amount I seem to be shifting each time is pi over n. And that's also borne out here by my delta x. So here, just like she says, the width appears to be pi over n. Pi seems to be the starting point. The function seems to be cosine. Everything seems good, right? So once I have n rectangles, that means I'm going to end, my total width is going to be pi. So she did this kind of weird thing over here with like delta x being b minus a over n. That works also. But I just think of it as, if I have n rectangles, and the width of each is pi over n, then the total width of the interval will be pi. And so this is going to be the integral from pi to 2 pi of cosine x dx. Everyone cool with that? Which, by the way, is what? 0. Which is 0, right? Because all of this is balanced out by all this. But I didn't ask you to do that, but anyway, that is the answer. All right, more. Integral from -2 to 1 of just the function 4. Okay, well, width of 3, height of 4, answer 12. 4 is the integral from root 2 to root 18 of just the root 2 function, which is also a constant. So you just like boom, boom, you do it out, and you get also 4. Good. Number 5. This is the integral from -2 to 4 of just a line. And the line has y-intercept 3 and slope 1/2. So you can just kind of like plug it in, right? You plug in -2 and you get 2, and you plug in 4 and you get 5. And then you just have to figure out the area of that region. This person did it as just like a rectangle plus a triangle. You could also do it as a trapezoid. Is that the right answer? No. Oh, what happened? Bad geometry? 6 times 2 is 12. Oh yeah. Isn't it height 2? What happened? That number should be a 2, right? Then is it right? The answer is 21, right? Yeah. So yeah, the height of the rectangle is 2. So that should be a 2. So that's a 12. Answer 21. Okay, 9 is the integral from -3 to 3 of root 9 minus x squared. Okay, we did problems like this before. Root 9 minus x squared is just a semicircle with radius 3. So that's going to have area 9 pi and then divided by 2 because it's just the top half. 7, integral from -2 to 1 of absolute value x. Well, that is this thing, and then you make a graph, and then you just compute this. This is going to have area 2, and this is going to have area 1/2, so it's 2.5, so answer 5/2. All right, now we get into some more complicated ones. 2 minus absolute value x. You take absolute value x, you flip it upside down, you move it up 2. This is just like a function transformation exercise, and you go from -1 to 1. So you get this little like house-shaped thing, which has area 3. Questions? Okay, now they get even harder. What's going on now? Now we take actually it's not that hard. We take a semicircle and we just move it up 1. So it's the integral from -1 to 1 of like a moved up semicircle. So this person reasons that it's just the area of this rectangle plus the area of this semicircle, which is exactly correct. So you get 2 plus pi over 2. Questions? Are you going too fast or we're okay? It's not that hard, I guess, right? Next one, the integral from a to 2a of x dx. So now we get this kind of shaped region, and this person chooses to do it as a trapezoid. And what is the area of this trapezoid? It's the average of the bases times the height, or 1/2 height times the sum of the bases. So that's 1/2. The height of the trapezoid is a, the distance between the bases, and the average of the bases is 3a over 2. So you end up with 3/2 a squared. All right, now let's talk about the back of the worksheet, or the second half of the worksheet, which I thought was more exciting, which is really just one problem. This is basically just function. This is just how well do you know your function transformations from like pre-calc A, plus some little bit of calculus mixed in. So all right, they just tell you on this worksheet, or I just told you that the integral from 0 to 1 of x cubed was 1/4. We're good by now, right? We know how to do this. We just set up the Riemann sum and you do it all out. It takes, I don't know, 5 minutes. So just trust me, that's right. And now, using that fact, do a bunch more problems, such as number 11. What's the integral from -1 to 1 of this? Well, the answer is 0, right? Because each one of these y values is canceled out exactly by one of those y values. And in fact, if there's any odd function, the integral over a symmetric interval around 0 will be 0. I'm going to say that again. You guys know what I'm talking about.
Like negative A to
Yeah.
A.
That if you take negative a, if you take the integral from negative a to a of any odd function, it's guaranteed to be 0 because it balances out. Okay, that was 11. 12. The integral from 2 to 3 of x minus 2 cubed. That's exactly what we were talking about over there, right? This seems hard because I only know about this integral from 0 to 1, but then I realized, based on this gorgeous picture, that if you move this function over 2, then the integral from 2 to 3 of this function is just got to be the same as the integral from 0 to 1 of my original function, so it's also 1/4. Questions? Newman, you good?
Yeah.
Okay, 13. The integral from 0 to 1 of x cubed plus 3. Well, this person draws a picture and they realize, well, this is going to be basically 2 regions. One of them is just a 3x1 rectangle, and the other one is just the region whose area I already know about. So it's just 3 plus a fourth, or 13/4. How about 14? This is the integral from -1 to 1 of the absolute value of x cubed. Well, now that's just kind of like the x cubed function, but always positive, so it flips up and it looks exactly like this person drew here. So the integral from -1 to 1 is just going to be 2 of those little areas that I know about, so the answer is 1/2. All right, now they start getting a little harder. 1 minus x cubed. All right, we have to correctly graph this. So that's the normal x cubed, looks like this. So now we have to flip it upside down and move it up 1. This looks pretty good right here.